And should we go ahead and get started?
Yeah, let's get going.
Okay, great. Hi, everybody. My name is Nuala Mullen. I am the business development lead for safety services at Rockwell Automation for North America. And today I have with me my colleague, Robert Bertley, who is also a business development lead. He and I have slightly different areas of expertise. Mine is lockout tagout. And if you are interested in more information on that, you can go to the first first episode in the webinar series where I spoke about lockout tagout. But today I'll be turning it over to Robert Bertley to talk about ArcFlash. Robert?
Thank you, Nuala, and thank you everybody for joining. As Nuala mentioned, the focus of our discussion today is going to be centered around ArcFlash. So I'm going to spend majority of the time kind of covering typical aspects of a generally speaking, an ArcFlash program for a company, and geared towards what are some kind of basic and industry best practices, and then things you can do with that program and various facets to kind of push towards optimization and really getting gold star, so to speak, from the ArcFlash documentation and compliance standpoint. So if you have any questions, as we go, feel free to ask. Otherwise, at the very end, we can do a Q&A session. I can certainly address any questions that you might be thinking of as we go during that Q&A towards the end. So I guess a little bit of a level set. So to start, I'm sure many of you on the phone are familiar with what an ArcFlash is, but I'll just highlight it pretty quickly here. But an ArcFlash, occurs during an electrical fault or short circuit condition, which passes through an arc gap. An arc flash can be initiated many ways. So it could be through accidental contact with an energized electrical circuit. You could have equipment at a facility that's technically underrated to handle the available short circuit current in a particular circuit. That causes an electrically unsafe condition. Your equipment could have some contamination. It could be deteriorated or corroded, and that could lead to an arc flash event as well. So in summary there, an arc flash event, it could occur via a manual interaction or physical interaction from an individual working on an electrical enclosure, or it could happen totally by accident via just an equipment failure for some of those factors. But an arc flash event itself can expel large amounts of electrical or energy in general, excuse me. The arc, part of the arc flash event, it causes an ionization of the air. Temperatures of an arc flash event can get up to 35,000 degrees Fahrenheit, which is about 3 times the temperature of the surface of the sun. That kind of temperature, of course, when exposed to, could have several bad side effects from the safety and injury standpoint. But it can set fire to clothing and severely burn human skin. It could ignite nearby combustible materials if you're in a particular environment that has some combustible materials or processes. It usually more or less vaporizes metal parts of whatever electrical enclosure the flash initiates from, which could vaporize those parts and send flying shrapnel through the air, causing not only danger to the person interacting with that piece of equipment specifically, but also other employees or personnel who may be in the area. There's typically a pressure wave associated, depending on the size of the arc flash event. It could be a fairly sizable pressure wave that can knock an employee or worker off balance. Let's say, for example, if employee is on a lift working on a piece of a disconnect on the overhead bus duct, or is on a ladder to access a panel or piece of equipment that's elevated and not accessible from the floor level, a pressure wave or blast like that could knock that person off that elevated equipment and cause a fall hazard in addition to the flash hazard. There's a sound blast that can damage hearing, result in temporary or permanent hearing loss. And then the flash itself from the arc flash event can result in temporary or permanent blindness depending on the severity. So of course all these various side effects, depending on the size of the arc flash event, could result in, injury to personnel, potential serious injury, or even possibly death. And almost certainly is going to cause some significant equipment damage as well, for the enclosure where the arc flash event occurs, and maybe impacted equipment around the area as well, which almost certainly cause some downtime and need to replace equipment and some unplanned costs. So how do you deal with this arc flash, hazard is the question, I want to ask. So we're going to use populate this here. We're going to use kind of like a 3 use case for each slide that I bring here for various aspects of what an arc flash program is. So explain the goals and benefits of implementing a program. So I'm going to highlight some basic compliance goals, some common pitfalls, as well as best practices and things you can do to move your arc flash program towards total kind of optimization, like I mentioned before. So the reason I want to highlight like these 3 different kind of buckets, right, the basic compliance, industry best practices, and program optimization, is that a lot of people, even some employers or companies, think of arc flash compliance as simply a checking the box type situation, and they like to do the bare minimum required, just to achieve compliance with NFPA 70E or OSHA, for example. But if you put a little bit of thought and some extra effort into your arc flash program and electrical written safety program, you can really yield some good valuable results and improve efficiency, for a facility in the long term. So in addition to knowing how severe the arc flash hazard may be at your various pieces of equipment in your installed base, probably may also want to think to yourself, wouldn't it also be nice to understand how I can reduce those hazards? So if an arc flash event does occur, it's not as severe as it could potentially be. How do I reduce that hazard and improve employee safety and minimize damage to my equipment? Or how could I minimize the PPE that my employees need to suit up in if they're going to go work on equipment while it's energized, so that they can effectively do servicing quickly and efficiently without impeding production? Maybe how can I optimize settings of the equipment in my current installed base, my current circuit breakers? How can I look at maybe making modifications to my fuses so that I can avoid potential nuisance trips, which also cause unexpected downtime as well? So the industry best practices and program optimization sections will give some context and suggested techniques regarding how to move towards that type of program effectiveness. And so you can use your arc flash study and arc flash overall program and corresponding written electrical safety program as a tool to improve that efficiency instead of just simply checking the box for the sake of compliancy. So in terms of the key components of an arc flash program, this is just a high level summary. So there's more specific individual components you want to have than this, but these are the main factors which are good to highlight. But you want to obviously have an electrical safety policy in place as typically as a first step of developing your arc flash program. But that'll be a written program or document which defines guidelines, policies, and procedures for working on or around electrical equipment. Documents, how your employees are going to understand arc flash hazards, and defines guidelines on how those employees are going to work on energized electrical equipment, and guidelines of how your organization specifically will approach electrical work, generally speaking or as a whole. Another component is the hazard identification, which I'm going to dig into a little bit deeper shortly here, but hazard identification meaning getting an updated arc flash analysis completed for your facility, which will tell you, how much arc flash risk there is at each of the enclosures in your electrical distribution system. Hazard mitigation is a good component of an arc flash program. Frankly, a lot of programs are missing this one piece. But if you can determine, like I mentioned previously, how you can potentially reduce your arc flash hazards, either you deem unacceptable per your electrical safety policy, or things you just want to plane lower to make servicing equipment more efficient, faster, easier with less PPE, a good hazard mitigation plan should be something that's part of your overall program. Protective, personal protective equipment, or PPE, is a more of an obvious component, but once you understand the arc flash risk after you've done an arc flash study, of course, I want to make sure that you have arc flash PPE available for your employees, so they make sure that they can suit up in proper PPE if they're going to work on electrical equipment. Also, you should ensure that the PPE remains in good condition. You have measures in place to check for the condition of PPE, maybe limits on how many times a pair of gloves could be used, for example, and things of that nature. So the health of your PPE program remains in a good state. Employee training will be for, I guess, both your qualified and unqualified employees, but focused on your qualified employees typically for energized work, so that they understand arc flash hazards. They're able to interpret, an arc flash label, so they understand, what PPE they need to dress in when they're doing energized work. They understand, various, shock approach boundaries when they're working on equipment. So they're not only protecting themselves as much as possible, but they're also protecting other individuals and employees who may work in the facility as well while they are doing those energized tasks. And lastly, another component that's often overlooked is general program maintenance. So it's often neglected as part of many arc flash programs, but after an arc flash study has been completed, safety policy developed, employees trained, it's important to make sure you have kind of a methodology to keep the arc flash study updated regularly as equipment changes occur in the facility. Also, to keep your employees trained, over time, have them retrained, make sure you have a mechanism for new employees you may bring on board to get trained and things of that nature. So that's a very quick high summary of some of these key components at a high level. Now we're going to take a little bit of a deeper dive into a few of these and go into more detail on them. So, starting with the written electrical safety policy, but your safety policy should be kind of a living, breathing document, which will always be a go-to place for employees to reference back to in order to understand procedures they need to follow for working on energized equipment. What specific steps or processes they need to take when they're going to be doing that work. Maybe there's like an electrical work permit type of component. That's part of that program, but it should be readily accessible to your employees, and they should understand, where to find it and what guidelines and policies are listed throughout that document, and make sure they follow those. So to hit on the basic and industry best practice and program optimization standpoint from the policy perspective, if you're looking for basic compliance, you need to have a program documented, per NFPA 70E. It should define the purpose and scope of what the program is for basic compliance. It should give some definitions and context so that employees understand, they're to execute electrical work in a proper fashion. Should identify what your organization deems required for an arc flash study, including how calculations are performed, how labels are generated and installed, how employees get trained. From the industry kind of best practices perspective, defining responsibilities and ownership, kind of will help you take a next step there. As well as documenting specific processes. So like, what do you do when, there's a change to your equipment base? If you're moving a production line from one area of the facility to another, maybe you're changing where it's ultimately fed from in your electrical system when you do that. If you have some sort of plant expansion, you're adding electrical equipment, how do you get that, incorporated into your overall arc flash program? How are you going to maintain that over time? Also, the utilization of written electrical work permits is a good industry best practice as well. So what a work permit is essentially it's a worksheet. You can pull one right out of the NFPA 70E standard, but it's a worksheet that a qualified employee who is going to need to perform an energized work task will fill out. The default version you can pull out of the 70E standard has a good amount of inputs on it, but they would record what specific piece of equipment are they going to be working on. After they have, looked at the arc flash label that's on that equipment, they would detail, the incident energy level of the equipment, what the arc flash hazard is, what the various approach boundaries are. documenting the specific PPE they're going to wear when they service at Energize based on the results of the arc flash study, things of that nature. So typically there's also a like electrical safety program champion at a facility who will review that work permit that's been filled out with the qualified employee and sign off on it in agreement that all the work steps documented are the proper steps to follow, so that that qualified employee is minimizing his risk while working Energize as much as possible. And then working towards the kind of program optimization standpoint, making that arc flash policy accessible to all of your employees. Maybe if you have an overall corporate policy and you have several individual facilities scattered about that need to follow the same policy, it's important that everyone always has access to the latest and greatest copy that might have the latest applicable updates, guidelines, company policies, specific procedures, etc. documented in it. Another thing that's often neglected is a documented process to work with contractors who are in the facility. So whether that's like a controls contractor that comes in and does controls work at your machine level, it's important that individual or those individuals who work in your site are aware of the specific electrical hazards and follow all of your electrical rules and guidelines, right? We don't want someone coming into the facility and doing things in their own way, which may violate your policy. If you have like a local electrical contractor that you use to do some hands-on, energized electrical work, it's important that they're following your policies as well. They're using the local work permit process. They're checking in with your site safety champion as they're doing their day-to-day job or task, and make sure they're staying in compliance with that as well. So also just general enforcement. So that's another key when you're looking at program optimization and kind of a health check to make sure it's as healthy as possible and being utilized. So things like auditing employees to make sure that they understand where to find the program, they understand the contents within it, is a good way for enforcement. Providing training on that policy at your regular intervals, doing refresher training on that policy, especially if any revisions get made to it and any specific content or maybe organization specific changes get made throughout. So the next thing we're going to dig into more thoroughly is what's a good practice for getting an actual arc flash study performed. So there's two standard methods for performing, I guess, generating arc flash labels and determining PPE requirements when working on energized equipment. The first method is called the PPE category method, which is also referred to as the table method. You may have heard that terminology before. That's more or less just an estimated PPE category based on some equipment specific characteristics, but there's a lot of limitations with that method. It's not an extremely exact science, and it doesn't include any specific detailed engineered calculations to determine the incident energy or arc flash hazard for your enclosures. The other method of understanding PPE requirements and evaluating arc flash risk at your enclosures is to do what's referred to as the incident energy analysis method. That's a detailed engineered arc flash analysis, essentially. And if you were to look at the arrow on the screen from the bottom left towards the top right, that outlines the typical steps that get followed in order to perform an incident energy analysis. So the first step in that process is typically a field data verification or data collection step, where an arc flash technician or electrician or electrical engineer will visit your facility and will capture all of the field equipment, electrical equipment characteristics installed in your facility, capture those characteristics, things like wire size, length, and type going in and out of each device, nameplate info for your devices, manufacturer, make, model, specific settings of your circuit breakers, things like that, starting from, if you can see my mouse, the incoming utility transformer at the facility on through the various three-phase loads in the system. The next step is that field data that's collected gets modeled in an Arc Flash software package, where we're essentially building out a one line, like this bottom left portion of the screen, and building a virtual model of your electrical system as installed today into this Arc Flash software package. The software is used to perform an engineering analysis and generate the incident energy level for each enclosure or node analyzed in this study, which is eventually, when you fast forward to the next step, going to get applied to a label that gets affixed for each node in the system or enclosure. And this label is going to be what your qualified personnel use, like I mentioned before, to understand what PPE requirements, if this piece of equipment is going to be serviced well energized. Also, it's going to define various approach boundaries as well, which are important to know. So maybe physical barriers can be set up, things of that nature, to keep general personnel or unqualified personnel out of a potential hazard area when energized work is taking place. Other typical info on labels that's kind of above and beyond requirements, but our best practices are, equipment name descriptions, a quick verification that the label is installed on the right piece of equipment, information on what upstream protective device is protecting the piece of equipment that this label is affixed to for quick troubleshooting or de-energization if needed. Also, the date of analysis is important too, so you can do a quick check to see if an Arc Flash study is recent or current, or if you feel it may need to be updated, whether 5 years has gone by since it was done last, or if some change of this branch of your electrical system has taken place recently after the date that's listed on this label. And then applying those labels to your various enclosures is a step of the process as well. There's generally a report also provided. Best practices report usually has a short circuit study included. A short circuit study is performed and basically flags any protective devices that are not adequately rated to handle a short circuit or a fault event. And it will give some recommendations on how you can proactively change those fuses before they may potentially fail. Protective device coordination is generally provided, and that study, it helps you optimize the settings of the protective devices in your system and your circuit breakers, so you can improve overall system coordination, help avoid nuisance tripping, reduce Arc Flash hazards for downstream equipment in some cases as well. And then, of course, the Arc Flash study itself, which tells you the incident energy level available at your various pieces of equipment, details the PPE requirements when you're working on that equipment. A lot of times, a report will have some recommendations for Arc Flash hazard mitigation and improvements as well. So in terms of the Arc Flash study analysis, to do a quick map of our basic compliance industry best practices and optimization. So basic compliance would be the incident energy levels calculated for your enclosures. A report is generated and provided which lists that incident energy level for each enclosure. Labels are affixed to your enclosures which state what that incident energy level is. Moving towards the best practices, your Arc Flash label should display the upstream protective device information. Coordination recommendations should be identified to help avoid nuisance stripping. Recommendations to reduce your incident energy level as well could be provided. Like I mentioned before, those changes may include modifications to the settings of your existing circuit breakers. A lot of times there's cases where you may have existing breakers, and if you were to set or change the setting of like the instantaneous trip setting or some other dial settings, you could pretty easily and very quickly reduce the downstream Arc Flash hazard for the panels and enclosures that are downstream of that breaker. Some of the recommendations may be more complex, but maybe something you want to look at as well. They could include replacing or retrofitting your equipment, inserting new equipment at various places within your system, things of that nature. Accurate one-line drawing should also be produced and provided as part of that service as an industry best practice. And then working towards the program optimization standpoint, Maybe you can tailor your mitigation recommendations to your specific application or needs in order to maximize overall value. So like I mentioned, simple recommendations like changing those breaker settings could be applied by your own internal personnel in many cases, quickly at no cost, sometimes without requiring de-energization, depending on the breaker that you have installed. Sometimes you can do that very easily and quickly during a scheduled shutdown. And also defining an acceptable risk limit should be defined in advance of the study, so that you can help determine which specific mitigation solutions you're going to implement. So you may determine that as a company, your acceptable level of risk in terms of doing energized electrical work, you may say, I'm only going to allow my personnel to work on electrical equipment energized if the incident energy level is 12 cal per centimeter squared or less. Well, then you want to document with the arc flash provider that you use to do the study to provide mitigations for equipment to reduce it to the less than 12 cal per centimeter squared hazard, so that energized work can be prohibited when needed for that equipment. Or for example, if there's equipment that you service or access frequently while energized for one reason or another, you may want to target and make your provider aware for those specific panels or enclosures or equipment, to highlight some recommendations for that. Typically, when possible, utilizing a recommendation with your installed equipment base that you already have. So you don't need to worry about additional costs, if that makes sense, of course. You don't need to worry about additional costs to buy replacement equipment and have that installed, etc. So if you follow this type of strategy, you'll be able to potentially complete a good chunk of the risk reduction, system optimization, and have some real time and cost savings over a longer duration, rather than waiting until the study is completed to make your improvements. So another key part of the program is employee training. The employee training includes qualified employee training. So qualified employees are those personnel who work on or in energized electrical equipment. Training should equip that personnel with the knowledge specific to their respective job or task assignments that they do with the facility. Training should include topics like awareness of arc flash hazards, properly reading an arc flash label, selecting proper PPE, maintaining PPE for doing energized work, and also understanding your procedures and best practices to follow during their energized work, usually tied back to that company electrical safe written policy document. Unqualified employee training should be provided as well. This is unqualified employees are more general employees in a facility who do not directly impact do not directly interact with energized electrical equipment as their main job task. So think employees like office support employees, machine operators in some cases who may do specific tasks at the machine level or at an operator station, but they're not actively opening up electrical enclosures while they're energized to service them. Typically, this is pretty short, a short training compared to the qualified electrical training, but it's still important to make those unqualified personnel aware of hazards that exist, so that they don't accidentally find themselves in maybe a potential situation where they're putting themselves at risk, because of lack of knowledge, or maybe they may interrupt a qualified person while they're doing an energized task, which is not an ideal scenario either. So training content can include typically live instruction, right, by a live instructor in a classroom type setting. Could include some videos to give visuals of an actual arc flash event. There's plenty of those videos floating around on the internet that can be viewed to give an idea of the severity and seriousness of what an arc flash hazard is. Hands-on work is a good or hands-on training is a good component to have in your training program as well, just to make sure personnel who are tasked with doing electrical work can really translate their training into real life energized work scenarios when safety is really important. So in terms of the our basic and best practices and program optimization from the training standpoint, basic compliance for training is really just to do it. So you need to make sure your qualified and unqualified employees are trained, on arc flash. And if PA 70E requires the training be done at durations not to exceed 3 years. So basic compliance, we're likely talking, like an in-person lecture type classroom scenario that's going to incorporate, some videos, or, reinforce some content. But leaning towards the industry best practices, considerations is making the training interactive so that your employees, especially qualified employees, like I mentioned before, who actively engage, in energized electrical work, do some hands-on examples in a classroom setting before they go out and do some live work on the floor. Maybe that hands-on component also includes pulling up an arc flash label from an actual panel or piece of equipment out on the floor, going through specifically the considerations to take on that specific piece of equipment. So it's a good hands-on example. Going through the work permit process, maybe performing an actual task at that equipment with the PPE suited up to get some experience there, rather than just the training being totally theoretical in nature. And then also giving a competency quiz is a good industry best practice as well, because you want the personnel who got trained, make sure they are understanding and retaining the information, that's being given by the instructor. So you can set, a fairly aggressive pass or fail level for a competency quiz for those personnel who may not pass the quiz after the training or through regular intervals during the training. It's recommended to either retrain those employees altogether or spend some extra time with them to retouch on the topics that they may be struggling to comprehend. So we make sure they don't have any gaps walking out of a training session. And then when we're talking about program optimization, so focusing on key ideas, by group is a good strategy. So keeping the qualified and unqualified personnel training separate. There'll be a lot of content that qualified personnel need to be trained on. They need to understand that's not going to apply to unqualified personnel. Rather than forcing unqualified personnel to sit through a long training, maybe they can be dismissed after their applicable content has been covered, and that'll give the qualified folks kind of more one-on-one interaction with a smaller class size with the instructor. Maybe they'll get some more comprehension and more things stick in that kind of smaller classroom environment. Tying some training content, like I mentioned before, back to your own written policy is very helpful. So for example, if your policy forbids energized work on equipment that exceeds a certain incident energy level threshold, I used the example previously of 12 caliber centimeters squared. You may want to include some content in your training material that's specific to your company policy so that your employees understand if something is rated greater than 12 caliber centimeters squared, they're not to perform any energized work under any circumstances. And maybe the best solution is to look at engineering out to mitigate that arc flash hazard. So if something needs to be service energized, fairly often it can be done so within your parameters of your decided acceptable level of risk. Also, in terms of optimization, it's helpful to keep logs of employees that were trained, when they were trained. Really, this applies all across the board for all three buckets, basic, best practices, and optimization. But I'm always fairly surprised to see a lot of customers don't document, their personnel training when people have been trained, and a lot of times there's compliance gaps out there because that training may exceed a 3-year duration, or they may hire on a new employee who doesn't get put through training before they're put out on the floor doing work. So keeping your personnel trained and knowledgeable on the hazards in your electrical policy specifically won't just check the training compliance box, but to give you some long-term value and efficiencies by making sure your employees know your best practices and most efficient procedures to follow while they are doing the energized work. So help with overall efficiencies there. And then lastly, we're going to touch on arc flash maintenance. So how do you maintain your arc flash study or program as changes are made? So I pulled on this slide literal wording out of the NFPA 70E 2018 standard, but it says arc flash analysis shall be updated when changes occur in the electrical system that could affect the results of the analysis. The incident energy analysis shall also be reviewed for accuracy at intervals not to exceed 5 years. So what does that mean? That means if you have, let's say you had an arc flash study done yesterday and fully completed, and you label affixed to your enclosures, but next week you go through and make a bunch of changes to your circuit breaker settings, you change fuses out, things like that. You need to update your arc flash study after those changes are done so that the labels put out in your enclosures are updated with your current installed base. You should also get your arc flash analysis documentation updated as well so it matches. And like I mentioned during the training content, previously retraining on the safety related work practices and changes in the standards shall be performed at intervals not to exceed 3 years. To break that out into our 3 buckets again, from the basic compliance standpoint, it's helpful to document system changes whenever they take place. Whether you're unsure if they impact arc flash or not, it's good to jot those changes down and keep a running log or journal of what those are over time, so that when it comes time to update your study and when you're ready to move forward with that, you have a targeted list of what needs to be updated specifically. In addition to you then not having any gaps out there, that also typically helps an arc flash provider most cost effectively update your study as well. There's not going to be lost time on site trying to understand and recapture changes that have been made. If you have a targeted list of items we know need to be evaluated, it makes the site work portion, the data collection and label installation for an arc flash update much more efficient. You should refresh the arc flash study after 5 years have passed. Per that guideline I had in the last slide from an FPA 70E, perform refresher training for your qualified employees and training in general after 3 years. Moving towards the best practices kind of bucket, they have a routine schedule and procedure for documenting system changes in one place that people from multiple departments, for example, can access. So maybe if you have a maintenance team at your facility, you have a separate electrical team, you have a separate engineering team. If they're all tasked, they work on different projects. They may not all work on things in a consolidated manner. It's helpful that they can put all of their changes either in a single log or maybe individual logs, but they get stored in the same location, like a shared network drive, hard copy in a single location, etc. So all the projects that may impact the arc flash study are documented in a single location. I say routinely review and implement mitigation recommendations that may be made from your arc flash study. And then update your study periodically after changes get made, so you make sure your labels are affixed to equipment, supporting one-line drawings and documentation gets updated. Moving out to the best practices section, I'd say proactively allocate additional funds when you're working on some of those projects, so that you can budget arc flash study program updates packaged in with those projects, rather than treating arc flash as an afterthought, saying, hey, we had this project, we either had an expansion or we moved some equipment around, we got that project completed under a certain budget. Now we need to go get a proposal from my arc flash provider to update my arc flash program, and then apply for separate funding, for example, based on after the work has already been completed. If you do that arc flash budgeting in advance of work being completed, a lot of times you get those updates knocked out perhaps in the same budget that you have for the project. And also having a structured method to continually implement mitigation recommendations, update the study, and keep employee training over time, some sort of maintenance program or a long-term annual contract with your arc flash provider, and sticking to a schedule to keep those things updated, help make sure that things don't get overlooked over time. It's a really good way to protect your initial investments, and not only keeping your arc flash updated, but if you're tacking on changes and keeping your arc flash documentation updated regularly as those changes take place, it's generally more cost effective to do that over a 5-year period versus waiting the NFPA 70E requirement of only touching and updating your arc flash study after 5 years have gone by. So I know I moved through that content pretty quick there, and I didn't hit on every aspect of arc flash, of course, but through the things that I touch on, or if there's anything that I did not touch on that you're interested or curious about, I can open up the floor if anybody has any questions. I'll give it just a few more seconds, but maybe the silence is a sign that we don't have any specific questions. I will also say, if any follow-up questions come to mind, or if you review any of this content that I talked about or learned, or you share the recording or have the recording, look through it in the future and more things come up, please do feel free to reach out to your HESCO or Rockwell automation team, and we will make sure that we get them addressed post haste.
Great. Thank you so much, Robert.
No problem at all. Thank you everybody for dialing in. And like I said, any other questions come up, just let us know. We'll be happy to answer them. And everybody have a great rest of your day and a great week.
Thanks, Robert. You too.